Okay, so now for these are going to be using the Rydberg equation for hydrogen. So calculating the frequency of the light that's emitted when an electron is going to make a transition. So the equation we're going to be using is that the change in energy of the photon emitted, the emitted photon, is going to be negative Rydberg's constant for hydrogen times 1 over N final squared minus 1 over N initial squared. Okay, so this is what we need to do first. We need to find the energy of the photon. All right, so we're going to take negative, and then the Rydberg constant for hydrogen is negative 2.18 times 10 to the negative 18th joules. And we are finishing at n equals 3, so it's going to be 3 squared, and we're starting at 4, so it's going to be 4 squared. And we're going to get an answer in joules. So it's going to give us our delta E of the photon. So I'm going to subtract these fractions here. I'm going to assume that when you square 3, you get 9. So I'm going to get 1 over 9 minus when you square 4, you get 16. Okay. Now negative times negative is positive. 2.18, 10 to the negative 18th. So that tells you the energy of the photon, 1.06 times 10 to the negative 19th joules. All right. Now, we also know that energy of a photon is equal to Planck's constant times frequency, right? So the frequency would be energy of the photon divided by Planck's constant. Do we agree? I hope so. So that's going to be 1.06 times 10 to the negative 19th. So frequency is going to be 1.06 times 10 to the negative 19th joules. Divided by 6.626 times 10 to the negative 34th joule seconds for Planck's constant. Frequency is an inverse unit, so seconds should be in the denominator. That's correct. So let's just divide that by h, get a number. 1.6 times 10 to the 14th. And you can say inverse seconds, or you can say hertz, and such. All right, so let's do another one. Same procedure. All we're doing is just changing these final and initial. So our energy of the photon, emitted photon, if you want to put the negative in there, that's fine. That is the most correct way. If you don't, and just say, I know they're going to cancel out, so don't worry about it. 2.18 times 10 to the negative 18th joules. 1 over our final, which is going to be 1, minus 1 over 5 squared. So 1, well, here we say 1 squared. 1 squared is 1. So 1 over 1 is 1, minus 1 over 25 times, we say this is going to be plus 2.18 10 to the negative 18th. So that gives me 2.09 times 10 to the negative 18th joules. And now let's just divide that by Planck's constant. To get our frequency. So more frequency here, higher frequency, 3.16 times 10 to the 15th, and I'm just going to leave that as per second.